Good morning, everyone, and thank you for attending today's webcast, Autodesk Storm and Sanitary Analysis and Introduction. Our presenter today is Scott Hacker. He is a solutions engineer with Hagerman & Company. Before we get started, I'll let you know that you're in listening only mode. If you have questions during the presentation, you can type them into the question panel on the right-hand side of your screen, and they'll be addressed at the end of the presentation. As we close down the session today, you'll be prompted to fill out a survey, and we do ask that you take a few moments to fill that out. Also, this presentation qualifies for one AIA continuing education credit. If you would like to receive this credit, just leave your AIA number in question 3 of the survey. Additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. And with that, I'm going to hand things over to Scott.
Great. Thank you, Ashley. I appreciate that very much. Good afternoon to any of you who may be in the Eastern Time Zone, and good morning to the others who are in the Central, Mountain, and Western, if you happen to be there. Again, this is Autodesk Storm and Sanitary Analysis and Introduction. So we're going to try to do our best to cover some of the high points for the Storm and Sanitary Analysis add-on that is in your Civil 3D software. Okay, and you are in the right place. So let's get started, if we can here. There we go. All right. So I am Scott Hawker. This is Autodesk Storm and Sanitary Analysis and Introduction. I am Scott Hawker. I'm an AEC Solutions Engineer for Hagerman & Company. And just so you know, Storm and Sanitary Analysis software is included in AutoCAD Civil 3D and all editions of the Infrastructure Design Suite. So if you happen to have either or, you have Storm and Sanitary Analysis. It will be installed typically when you install your software, whether that be, again, from the standalone suite. Now, with that, the Storm and Analysis, the dynamic model elements are not limited to design and construction documents. So what this allows us to do is create more design scenarios during the conceptual plan so that we can stay ahead of the budget, ahead of the schedule, but we can also keep this model up to date. We can perform water analysis much earlier in the design process for multiple types of projects. We can design and analyze using SSA, and that's how I'm going to refer to it from now on. Storm and Sanitary Analysis is kind of a big mouthful, so we'll just call it SSA. So with SSA, we can design and analyze urban stormwater drainage network systems, highway storm drain catch basins and culverts, sustainable stormwater management, including water quality, detention pond and outlet structures. We can even do sanitary sewer systems, pump lift stations, and force mains. So again, during the webinar, we'll cover the product in what I would consider an administrative introduction. And what we're looking for here at Hagerman is if there is a demand for SSA that requires a more in-depth look than what we're going to see here, what we'll do is we'll probably make additional webinars covering different topics such as maybe pump stations or catch basins, culverts, etc., and take this forward into future webinars showing these processes more in depth. One thing I do want to point out, here's a quick look at Autodesk's 2017 product offerings. With our industries really converging and innovating more quickly, the time that is necessary to turn projects in and then back out is becoming something of a real issue among companies fighting for the same projects. So what Autodesk outlook is that they want you and me, companies, to stay on top of these innovations. such as construction companies that manufacture their own prefabricated walls, ductwork, media firms that take their cues from the automotive industry and visualize their entertainment properties such as Pixar, etc. A lot of those folks use the media products from Autodesk. Now that's in association with, obviously, our AEC products, and that's why we're here today. But just so you know that there's all sorts of things out there that will allow you to not only be on the cutting edge of technology, but it's going to also help you be on the cutting edge of winning work moving forward. In the future, we're going to see the successful businesses approach this idea and the practice in a new and dynamic way. The process of creation has evolved beyond a simple linear path with much more integrated cycles of input and feedback. So Autodesk is going to continue to be on the cutting edge of these new processes as they move forward. So let's start off with the interoperability of SSA with Civil 3D and Map 3D. So SSA shares your data with the pre-mentioned software. You can use GIS shapefiles, hydroflow storm sewers, land XML files. SSA can share subbasin, sewer pipe, and structure data, as well as drawings that can be loaded in as a background layer. It allows you to quickly digitize a network model, confirm the network layout, or enhance the output results. The software can also create plan and profile drawings automatically. This helps speed up the creation of your final deliverables associated with your engineering project. This type of process also helps us out with our schedules, our budgets, etc. Now these profile sheets, when we create them, they're going to include maximum HGL and EGL, critical depths, maximum discharge, maximum flow depths, maximum flow velocities, pipe dimensions, size, inverts, etc., minimum pipe cover, and sump and rim elevations. Now one thing to remember is that all of these elements are stored on their own individual drawing layers. So you can quickly change colors, line styles, text styles, etc. Okay, so you can incorporate and change the default settings such as colors and annotations to fit your company's CAD standards. What it also does is it doesn't rely on a style, which we hopefully have all taken on as a challenge to create our own styles, and really kind of lob this back into just plain old basic AutoCAD as far as being able to change colors, line types, etc. by layers, which I always feel is easier to do and much nicer to do in the long run. Now, some of the technical capabilities and functionalities that SSA has, we've already talked about the exchange of data with AutoCAD Civil 3D and Map 3D. So we're able to take the information from Civil, our preliminary pipe networks, we're able to export them out into SSA. We're going to be able to make any changes within SSA that we deem necessary and run it through the process. And then we're able to import that back into Civil and Map 3D and see the updates and the dynamic aspect of the interoperability here. Okay. We also have widely accepted hydrology methods such as TR20s, TR55s, the rational method, modified rational, etc. And we'll see that here also coming up on another slide. We also have advanced and sophisticated hydrodynamic routing. It can handle backwater, surcharging, flow splits, etc. We can also perform hydraulic analysis of pipes, open channel streams, bridges, culverts, roadway inlet catch basin, and more. We can compare pre and post development conditions, which is pretty nice. We can also perform analysis and design of detention and retention ponds, as well as perform analysis of stormwater best management practices, or BMPs, as we know them in the industry. We can also utilize the interoperability with GIS, or Geographic Information Systems. Autodesk is really moving towards being able to respond to the GIS formats and allow us as engineers and Autodesk users to be able to use that functionality. There's a lot of information that we can use that has already been generated via GIS. So what they're trying to do is make sure that we can perform efficiently and utilize what's already there without having to recreate the wheel, so to speak. Okay, and one other functionality is it supports both US and metric units. It also performs water quality modeling, support of networks of unlimited size, sophisticated output, providing detailed plan view plots, profile plots, time series plots, and then we've also have the ability to customize reports and templates for agency regulatory review. Now, some of the typical applications that we're going to talk about have been used in thousands of storm and sewer studies throughout the world and growing every day. Autodesk is really making itself a worldwide entity here. So probably at this juncture, not thousands, but tens of thousands of sewer and stormwater studies have been performed. Now, typical applications will include the design and sizing of drainage system components for better flood control, the design and sizing of detention facilities for better flood control and water quality, floodplain mapping, design and control strategies for minimizing combined sewer overflows, or CSOs, evaluating the impact of inflow and infiltration on sanitary sewer overflows, or SSOs, generate non-point source pollutant loadings for waste load allocation studies. That is a mouthful as well. And also evaluate the effectiveness of BMPs for reducing wet weather pollutant loadings, as we alluded to previously. Now with that, within the SSA program, there are several widely accepted hydrology methods that can produce runoff from urban areas, rural areas, etc., including time-varying rainfall, evaporative and standing surface water, snow accumulation and melting. Not really a big deal here in the south, but if you are one of our northern or northeast customers, or even our west coast folks, snow accumulation and melting does come into play. Rainfall interception from depression storage, infiltration of rainfall into soil layers, percolation of infiltrated water, interflow between groundwater and the drainage system, and nonlinear reservoir routing of overland flow. Now, these processes are achieved by dividing a study area into a collection of smaller subcatchment areas and basins, each containing its own fraction of pervious and impervious sub-areas. Overland flow can be routed between these sub-areas, between subcatchments, and between entry points of a drainage system. Now, some of these hydrology methods, in order to perform the processes that I just relayed to you, include the SWIM 5.0, TR20 and TR55, the U.S. Army Corps of Engineers HEC HEC 1, the rational method, the modified rational method. We even have the ability to use UK modified rational for overseas projects, specifically in the United Kingdom. We have the DeKalb rational method, the Santa Barbara unit hydrograph, the Delmarva unit hydrograph, long-term continuous simulation. Maricopa and Pima counties in Arizona, which use the Papadakis-Kazan method, and Harris County, Texas method. Now, some of the times of concentration that the software includes are, again, SCS TR 55 or Technical Release 55. This is a simplified procedure for estimating runoff and peak discharges in small watersheds. We also have the ability to use the FAA time of concentration. This calculates the time of concentration over a uniform slope and uniform cover, for example, airfields, thus the FAA portion. The Carter time of concentration, which predicts watershed lags for watersheds that have natural channels and partially sewered land uses. We have the Kirpic method for small drainage basins dominated by channel flow. We also have the kinematic wave, EPA swim only. We've got the Eagleson, which predicts the time between the center of gravity of rainfall excess and the peak of direct runoff. We also have the Harris County, Texas time of concentration. The largest city there would be Houston. And again, the Papadakis, Kazan, Maricopa, Pima counties, Arizona. And you can also define your own time of concentration, which is always nice. Again, Autodesk tries to keep certain aspects customizable. That is one big selling point. Now, the time of concentration is only selectable when the EPA swim sub-basin hydrology method is not selected, so please note that. When the EPA swim sub-basin hydrology method is used, the time of concentration is going to be computed by the kinematic wave method and cannot be changed. Now, Autodesk Storm and Sanitary Analysis also includes a rainfall designer, which after you select any location within the United States will provide the design rainfall for the specified storm frequency. Alternatively, a user-defined rainfall can be specified, again, customizable. The appropriate storm distribution can be selected and the design storm is then created. Now, multiple design storms can be created and analyzed. So we can use the site-specific storm distribution database with over 3,500 up-to-date rainfall recording stations across the United States. So that's a pretty large area in a very large cross-section, 3,500 sites. If you can't find what you need, again, you've got user-defined. Okay. Now with that rainfall designer, it's going to automatically determine your design rainfall based upon the location for 1, 2, 5, 10, 25, 50, and 100-year return frequencies. Now, we all know that Baton Rouge has had its issues over the course of the summer. We have also seen flooding within North Carolina, etc. So hopefully they did not use storm and sanitary analysis here, and they probably used pretty old or much older rainfall analysis in order to perform their 100-year floods. Now, again, 100 years, a hurricane and a tropical storm are a little bit more than 100 years. However, it probably could have been alleviated a little bit by using the software here. You can go ahead and define any storm duration, including multiple events at one time. We have numerous storm distributions, including SCS, Huff, Eastern Washington, Florida, Chicago Storm, Hurricane Hazel, and again, user-defined. Now, for the rational and modified rational methods, the rainfall intensity data can be defined by either the IDF curve, the intensity duration frequency, okay, defined by the table of storm durations in minutes versus return periods in years, okay, thus 5, 10, 25-year storm. And that is the most commonly used option. You also have the BDE, where the rainfall intensity is defined by a table of BDE coefficients versus return periods using the FWHA intensity equation. You also have ABCD, which is rainfall intensity data defined by a table of third-degree polynomial coefficients, A, B, C, and D, versus return periods in years. And you also have the intensity direct entry, a single rainfall intensity that is designed to be analyzed. Supported pipe shapes. What type of pipes does the software support? Well, we're going to start off with the very common circular. We're going to go with a rectangular, a filled circular sentiment, rectangular or triangular, rectangular, circular, horizontal ellipse, as well as vertical and semi-elliptical. We also have arch pipe, horseshoe pipe, egg pipe, and user-designed custom. Now we also have bucket handle pipe and modified bucket handle pipe for anybody who uses those. But these are the supported shapes that we can utilize here within the software and that the software will recognize. Supported open channel cross-section shapes. Now these are derived from EPA SWIM. They are a rectangular channel, a trapezoidal, triangular, parabolic, power function, and again user defined, which needs to be HEC-RAS-like, okay? Now pumps can be represented as either an inline lift station or an offline node representing, say, a wet well where water is pumped to another node in the system. Okay, and our pump performance can be defined by either volume versus flow, flow versus depth, flow versus head difference, variable speed pump versus depth, and design mode where all inflow is pumped out at the same flow rate. Now that's useful for preliminary design, which is really what we're talking about here, at least on the front end. Hopefully this is going to help us save all of that time doing different calculations, etc., moving forward so that we can see the issues up front, have time to make changes before we go to even 30% plans. Now the on-off status of pumps can be controlled dynamically by specifying startup and shut-off water depths at the inlet node or through user-defined control rules. Rules can also be used to simulate variable speed pumps that modulate the pump flow. Now, I've gotten you fairly lulled into a false sense of security here, so we're going to take a break from these PowerPoint slides for just a second, and I'm going to go ahead and play a brief demo regarding the interoperability here between Civil 3D and storm and sanitary analysis.
To give you a bit of background about this project, we have been tasked to design this proposed stormwater pipe network along a design corridor. We have already populated and labeled the pipe network in our roadway profile view, but we still need to verify that the pipe sizing is correct. In this scenario, we will be following the review agency's requirement of 3 CFS per inlet when we run the design in storm and sanitary analysis. Then we will update our Civil 3D model with the design. So let's take a look at the project. So you can see here that we've got our proposed stormwater design inside of our roadway corridor, right? And it not only is populated inside of the roadway corridor, but we do have our pipe running away from the corridor to a daylighting position so that it can drain away from our roadway. We also have our profile populated, not all of the piping, but with everything that's in the roadway, and then you can see that I've got my pipe in the last inlet before it starts to turn and run off site here. So as it sits, everything is labeled up the way that I want it to be. So now I've got to take it through design. So I need to bring it into storm and sanitary analysis to do that design. So what I'm going to do is I'm going to select just any piece of my pipe network. So I select one of the pipes, and I'm going to go up into my ribbon and select Edit in Storm and Sanitary Analysis. Pick my pipe network and hit OK. What it's going to do is it's going to open up Storm and Sanitary Analysis, and then we're going to create a new project. I'll just hit OK. It will finish up the import, which does take just a second. And we can start with our design. So you can see it brought in all of our plan view and our profile. These are static objects, but we do have all of our pipe network in so that we can start adding our flows. So as stated before, we're going to use 3 CFS per inlet. So what we need to do is we need to add that known flow to each one of our structures. So I'm going to zoom in. I'm going to double click on my first junction. So we will be adding them to this set of inlets here and the road crossing inlets. And then once it starts to go off site, we will leave these alone. We will just treat this as a junction as if it doesn't have any flow going to it. So I'm going to go ahead and double click on my junction. I'm going to give it an external flow with 3 CFS. And we could click on each one individually to do this. And we'd be able to add that external flow, or we can select them from our menu here at the bottom, or our grid view, and we can add them in one dialog. So I'll just click down through and add these in. 3 CFS for our baseline flows. Notice that whenever I select the structure, it highlights here in the model. So if I select this structure and it highlights, I know I don't have a flow for that, so I would continue on. So structure 2, we do have a flow. So I'm going to add my 3 CFS. I'll pick structure 12 and notice that that is the one I don't want to add flow to. So I'll go ahead and scroll down. I see there's still some structures I haven't added flow to. So I will add the flows. Again, these are external flows as if they're known flows. This should be the last structure that we have to add or add flow to. I'll hit OK and close. Now I'm going to go up and I'm going to tell it in my tell storm and sanitary analysis in my analysis options a start and end date for the analysis. So I'm just going to use a day. So we started at 8:20, we'll end it at 8:21. I'm going to go up and select Perform Analysis. It runs my analysis, and it highlights where I'm deficient. So if you remember from Civil 3D, all of the pipes were 18-inch or 18-inch concrete. So I can see that my 2 runs here of pipe are too small, or there's a problem with them. So I'll double-click on that conveyance link, and it tells me that I'm in a surcharge condition. So this means we either need to adjust some inverts so that the pipe will carry additional flow, or we need to just upsize the pipes. A good way to see this also is to go to the Output tab, or Output pull-down, and select Profile Plot. Then I can select my upstream inlet and just pick my outlet, and it'll select and run through the pipes connecting to the outlet. And I can show my plot. And as we can see, my max HDL is getting out of my inlet here at structure ID number 4, and it's out here also at 3. So we can do a couple things to fix this. Today we're just going to upsize the pipes and rerun it and see if we can carry our flow. So I'm going to simply double click on my conveyance link or my pipe, and I'm going to change the diameter to a 24-inch diameter and hit close. Same thing here. I'm going to go ahead and change the next downstream pipe to 24 because it's also in a surcharged condition. Now once I've changed those pipe sizes, I need to go back and rerun the analysis to make sure that my flow is being carried correctly. So I'm going to reperform the analysis and hit OK. And I don't get any warnings this time. I still like to go back and check and see where I'm at storage-wise inside the pipe. So I'm going to double-click on that first pipe we were having problems with, and I can see that my design flow capacity is 20.86 CFS, and my peak flow during analysis is 12.74. So I'm good to go on this pipe. Now I'll just double-check the second one. Same thing. Design flow capacity is 24.47, and my peak flow is 18.37. So once I'm the way that things are designed, and I'm ready to push this back to Civil 3D, I'll just save the file, and we will save it. It's the same model, and I will just call this finished design. Once the model is saved, then I could go back to File, drop down to Export, and export a hydroflow storm sewers file. This is a .stm file. This is the file that we will import back into Civil 3D to update our model to the current design. So I'll go ahead and just call this Design 1 and hit Save. And it exports everything out exactly as I have it designed inside of Autodesk Storm and Sanitary Analysis. So let's jump back over to Civil 3D and import the file back into Civil 3D and repopulate our model. Now that we're back in AutoCAD Civil 3D, we will zoom into the profile and show that it still reflects the old design, okay, or the preliminary design. The pipes that are in question are these two pipes right here. They're still 18-inch RCPs. Okay, notice that the labels and everything are set up exactly the way I want. So it'd be nice to be able to just import the design and have it update the profile automatically. So let's do just that. We're going to go to the Insert tab on the ribbon, and we will select Storm Sewers. I'm going to go out and I'm going to select the design1.stm file that I exported out of Storm and Sanitary Analysis. I'll hit Open, and it asks me if I want to update the existing pipe network or create a new pipe network. I'm going to update my existing one, and I'll zoom into the profile first. You can see that it has taken on the characteristics of what our design was in Storm and Sanitary Analysis. It's not only showed it physically for the pipes, but it's shown it for the labels. It's actually updated the labels. So we can zoom back and look at the plan view, and we can see that the structures are represented as they were before. All right, so it updated everything, but it didn't change all of my structures so that I have to swap parts and things of that nature. So I'm just going to pick one of the pipes, and we'll look at the pipe properties. And in the pipe properties, you'll see again that it is set to 24-inch concrete pipe. And that came straight from Storm and Sanitary Analysis. So as you can see, in 10 to 15 minutes, you're able to take a preliminary design for a stormwater pipe network in Autodesk AutoCAD Civil 3D, bring it into SSA or Storm and Sanitary Analysis for design, and then update the Civil 3D model with the appropriate design.
Now, as you saw with this demo, the dynamic aspects between Civil 3D and also with SSA work together hand in hand. Again, it really only took about 10 minutes to do exactly what he was trying to process here and change the CFS and find out where his HDL was going to pop off. So very powerful, dynamic, everything changes as far as labels and things of that nature. Okay. Now, SSA can also analyze simple and complex sanitary and combined sewer systems. Now, you can do this for master planning, rehabilitation, new design. You can include future growth. And as you can see, it will do model loop networks. It will do flow splits, combines, overflows, and storage capacity, analyze sanitary and combined sewer systems, manholes, inlets, sewer networks, pumps, lift stations, as we spoke about previously, control structures, force mains, construct network sewer models from CAD drawings or GIS geodatabases. Check the CMOM or the capacity management operation and maintenance capacities requirements for compliance. Fix and find sewer bottlenecks. Regulate flow to treatment facilities by determining the storage. Perform CSO and SSO mitigation studies while accounting for the RDII, the rainfall derived inflows and infiltration. The software includes a comprehensive table of typical daily average flows, which can be used to determine the sanitary loadings based on land use and population density. Now, does anyone have any questions that came up during the presentation? Again, this is just an introduction. As you could see by the demo, there's a lot more that can be covered, and we can definitely go ahead and cover those in future webinars if there's a demand for them. Anything really related to drainage per se will probably be better off if we just did those and took those offline. That way we could give you the time and energy it needs to actually fulfill the answers for those. I'll give everybody just a few more seconds. Question came up is how do you calculate drainage areas from contour data? You've got the ability within Civil 3D itself to calculate your drainage area from your surfaces and be able to calculate your watersheds and your flows directly within the Civil 3D software. The watersheds, they're going to be integrated with SSA. You'll be able to take that information in and utilize that within your SSA. I don't believe that it is manual input. We're trying to make sure that everything works as seamlessly as possible here. But I will verify that for you. All right, with that, just a reminder that Hagerman & Company is your full service reseller, and our services range from consulting and review of your existing products and recommendations on upgrades, etc., to application support and system maintenance. And we're going to be with you from the very start to the very successful finish. And with that, I'd like to thank you for attending. And a link to this recording of this webinar will be sent to you, I believe, via email. Is that accurate, Ashley?
That's correct. They will all receive an email with a link to the recording. And once again, if you could take a few moments to fill out that short survey, we would appreciate it. It will automatically appear as you close down the session today. And thank you for attending today's webcast, and have a great day, everyone.